Chapter 4, Section 6, the fundamental theorem of algebra. We've already been using it. I've told you about it. I just didn't tell you that was its name. But the fundamental theorem of algebra comes from what happens when we look at the degree of the polynomial and how many solutions it has. If you're looking at the chart right here, 2x minus 1, degree of 1, has one solution. X squared minus 2, degree of 2, two solutions. X to the third minus 8, 3 degree, 3 solutions. X to the third plus x squared minus x minus 1, degree of 3, 3 solutions. So Friedrich Gauss, German mathematician, Carl Friedrich Gauss, right, developed this idea, and basically it is, if a polynomial of degree n, where n is greater than 0, then the equation has at least one solution in the set of complex numbers, right? If polynomial of degree n, where n is greater than 0, the equation has n solutions, provided each solution is repeated twice, is counted as 2 solutions, each solution repeated 3 times is counted as 3 solutions, and so on. Basically, it's saying the degree of the polynomial is how many solutions it should have. It's not saying which ones are real or imaginary or complex, but it is telling you how many you should have in total. So if we look at A here, let me get my red pen. X to the third plus 3x squared plus 16x plus 48. It's in standard form. The highest exponent is 3. It's a degree of 3. So how many solutions? It's got 3. Go just a little bit wider than that. How many zeros does the function f of x have? It doesn't matter. 0 solutions. These two things mean the same thing. You make that a 0, and you look at the highest exponent value. It's to the fourth. Should have 4 solutions. Now, it's not saying which ones they are. We can use Desmos graphing calculator or factor and solve, or you can use the rational root theorem, all of those kinds of things. So, finding the zeros of a polynomial function. Let's find the zeros of this. How many answers should we get? How many solutions are there? There are 5. Okay, now, we should use the rational root theorem to figure this out, but I like to use the old graphing calculator to get us kicked off. So let's do x to the 5th plus x to the 3rd minus 2x squared minus 12x minus 8. Notice we get only 2 spots, but remember that -1 is being used twice because it's on that curve, that relative maximum there. And then 2 is being used. We expect 5, we only see 3. That means 2 of these are going to be imaginary, which means they are radicals. So we're going to have to do some dividing to get down to the quadratic that we can use to solve. So let's get started. Let's use -1 first. Let's see. 1, there's no x to the 4th, 1x to the 3rd, -2x squared, -12x, and -8. Drop the 1. -1 times 1 is -1. 0, -1, -1. Negative makes positive. 1 plus 1 is 2. -1 and -2 is -2. Negative makes -4. Negative and negative makes positive 4. That makes -8. That makes positive 8. That makes 0. We expect a 0 because it's on our graph. Immediately turn around and just take those numbers and do it again. -1 times 1 is -1. That makes -2. Positive 2 makes 4. -4 makes -8. Positive 8 goes 0. We expect a 0 because it was used. Now we're going to use the 2. And we're using exactly what we see because we're already out of the parentheses. And I'm just going to use those same numbers I just created. -2, 4, -8. Let's separate, drop it down. 1 gives me 2. 0 gives me 0. 4 gives me 4. 2 times 4 is 8, gives me 0. Now that's my constant plus 0x plus an x squared. So I have x squared plus 4 is my last factor. Set it equal to 0. Subtract 4. X squared equals -4. Square root both sides. Always get a plus or minus with square root. Now, square root of -4, it can't happen, so we're going to pull out that negative as the I, and then 4 breaks into 2 and 2. There's my pair. So it's plus or minus 2i. That's what adds up here. So plus or minus 2i. 1, 2, 3, 4, 5. All 5 answers. Negative 1 twice, 2, and plus or minus 2i. Okay, try some on your own. Come back, see how they go. How many solutions does the equation x to the 4th? It's got 4. How many zeros? Doesn't matter. Same deal. Make that 0. How many solutions? It's got 3. Find all the zeros of the polynomial function. Okay. X to the 3rd plus 7x squared plus 16x plus 12. We'll zoom in there. We got 1, 2. And negative 2 is twice. So we got x equals negative 3, negative 2, negative 2. Those are our 3 places. Hits negative 2 twice, coming and going, crosses at negative 3 once. We should get 3 answers. We did get 3 answers. Let's try the next one. X to the 5th minus 3x to the 4th plus 5x to the 3rd minus x squared minus 6x plus 4. Back to home. Boom, boom. 1 is used once, so we get x equals negative 1, 1, and 1. We should have 2 more, but they're going to be imaginary. This whole section is basically the last section, except that now you also get imaginary answers as part of your solution set. So let's do some dividing. I'll do negative 1 first. Let's see, 1x to the 5th, negative 3x to the 4th, 5x to the 3rd, negative 1x squared, negative 6x, and 4 is my constant. Negative 1 makes negative 4. 4 makes 9. Negative 9 makes negative 10. Positive 10 makes 4. Negative 4 makes 0. Perfect. Let's do 1. 1, negative 4. That's a positive 9, negative 10, and a 4. Separate, drop. Negative 3. Make sure I write the numbers down well. Negative 3, and that makes 6. 6 makes negative 4. Negative 4 makes 0. Running out of room, so let's do the other 1. I'm doing 1 twice because 1 is used twice. 1, negative 3, 6, negative 4. Drop the first one. 1 times 1 is 1. That makes negative 2. Negative 2 makes 4. 4 makes 0. So I've got 4, negative 2x, and an x squared. So I have x squared minus 2x plus 4 equals 0. It's not going to work. Can't factor it. And it's got too much stuff. This little guy says quadratic formula. Negative b plus or minus the square root. B squared minus 4 times a times c. All over 2a. Oop. Parenthesis. Silly. B is a negative 2. A is a 1. C is a 4. Negative and negative makes positive 2 plus or minus the square root of negative 2 squared is 4. Negative 4 times 1 is negative 4 times 4 is negative 16 over 2. 2 plus or minus the square root of negative 12 over 2. There's a lot of radical there. 2 plus or minus. Now, square root of 12 is going to go 3 times 4, which is 2 times 2. That comes out, but it's 2i because it's negative square root of 3. And 2 goes into both. So we get 1 plus or minus I square root of 3. 1 plus or minus I square root of 3. And there's not a way to check that you did that work right because imaginary places aren't in existence on the graph. But 1, 2, 3, 4, 5 places, and we got them all. You might be going, Mr. Maggie, you're going real fast. Well, it's all stuff we've done already. It's just like the last section. So yeah, we're going fast. Complex conjugates. Remember that I is the square root of negative 1. And we talked last section that if there's a radical as part of your solution set, you're going to have both a plus and a minus, a positive and a negative version of it. So the same things goes whenever we have an I because it is a radical. If you have a plus bi, you're going to have a minus bi. If you have 2i, you're going to have negative 2i. You're always going to have the conjugate. Okay? So, if they give you the zeros, they say x equals 2 and 3 plus I. Remember that you're also going to have 3 minus I. Write the equation. Okay, so turn them into parentheses. We did this in the last section. X minus 2, x minus 3 plus I, x minus 3 minus I. I would do the I parts first. I like to go with the trusty box when it's the I because it keeps it all together. X is 1, negative 3 is 1, negative I. X is 1, negative 3 is 1, positive I. It's just like the radicals. X squared, negative 3x, negative ix. I is a number technically, so the x goes at the back. Negative 3x, positive 9, positive 3i, positive xi. Oop, x not first. Positive ix, negative 3i, and negative I squared. That's important. Remember, that's a negative 1, and negative makes positive 1. This, just like the other radicals, this set and that set, this set and that set are like terms, and they're exactly opposite and cancel. So our like terms are here, and the 9 and the 1. So we've got x minus 2 times x squared minus 6x plus 10. And then we're going to finish it out. X times x is x squared, cubed. Negative 6x squared, 10x, negative 2x squared, positive 12x, negative 20. Like terms together. Negative and negative makes negative 8x squared. 10x and 12x makes 22x minus 20. Those should be our solution. There's a whole bunch to try. Go ahead and do that. Come back. See how it goes. All right, here goes number 5. We got x plus 1 times x minus 4i times x plus 4i. All right. That's an x. That's a minus 4i. That's an x. That's a plus 4i. X squared, negative 4ix, positive 4ix, and negative 16i squared. That's important. It's a negative 1. The negative makes it go positive. So we get x squared, these cancel, plus 16, times the one we didn't do, x plus 1. X to the third, x squared, 16x plus 16. Just like that. Let's try number 6. We got x minus 3, x minus 1 plus I square roots of 5. Ooh, getting crazy in there. X minus 1 minus I square roots of 5. And it's got an I and a square root in it. All right, let's do a big old box here. Plenty of room to write in. X minus 1 plus I square roots of 5. X minus 1 minus I square roots of 5. That's going to be all kinds of stuff we have to deal with. X squared, negative x. This box actually isn't going to matter. This box actually isn't going to matter. So we can just scratch it out. That box isn't going to matter. That box isn't going to matter. That's the pattern that happens. Only the real parts are the parts that we're going to really care about. So negative x, positive 1. These are going to be like terms. These are going to be like terms. Negative I squared, and then square root of 25, which is, that's a negative 1. Negative makes positive. Square root of 25 is 5. So we got x minus 3 still to multiply by, and then we've got an x squared, negative 2x, plus 6. X to the third, negative 2x squared, 6x, negative 3x squared, positive 6x, negative 18, 2, 1, 2, 1, x to the third, minus 5x squared, plus 12x, minus 18. Something like that. All right, x minus the square root of 2. But if we have the square root of 2, we also have negative square root of 2. If we got 1 minus 3i, we also have 1 plus 3i. So it's got 4 whole pieces to do together. So x plus square root of 2 times x minus 1 minus 3i times x minus 1 plus 3i. I'm going to do 2 boxes this time because I have all of that radical. That's going to be a big one. X minus 1 minus 3i, x minus 1 plus, I don't know why I put a radical in there. It's 3i. And then I need a 2 by 2 box. X minus square root of 2, x plus square root of 2. All right, start the big box. Then we're going to multiply the answers of these together. X squared, don't care, don't care, don't care, don't care. It's going to work its way out. Negative x, positive 1. Negative 9i squared. That's important. It's a negative 1. Negative and negative make positive. So I have to multiply x squared minus 2x plus 10 times, this is x squared. It's negative x squared to 2. It's positive x squared to 2. Those go away. And we get negative square root times itself. It's the number underneath. X squared minus 2. X squared times x squared, x to the fourth. X squared times negative 2, negative 2x squared. Negative 2x times x squared, negative 2x to the third. Negative 2x times negative 2 is positive 4x. 10 times x squared is 10x squared. 10 times negative 2 is negative 20. 2 things. 3, 1, 2 things. All right, so x to the fourth to the negative 2x to the third. Plus 8x squared plus 4x minus 20. Sticking them all together. Now let's look at 8. Eight's a monster. It's got 5 things. X minus 2, x minus 2i, x plus 2i, because it's always both kinds, negative, negative, opposite to get in, opposite to get out. X minus 4 minus the square root of 6, x minus 4 plus the square root of 6, conjugates galore. X minus 2 is going to be the last thing I do. I'm going to do x minus 2i, tail, x plus 2i, x squared, nobody cares, and we get negative 4i squared. That's important. It's a negative 1, makes it plus x squared plus 4. Okay. And then we also still have x minus 2, and we're going to have some other answer here. Let's do the bigger box. X minus 4 minus square root of 6, x minus 4 plus square root of 6. Don't care, don't care, don't care, don't care. X squared, negative 4x, positive 16. Negative square root of 6 and square root of 6 is 6. Like terms, x squared minus 8x plus 10. Oh man. Okay. Still got lots of bits and pieces to do. X times x squared is x to the third plus 4x minus 2x squared minus 8. And other than them being out of order, there are no like terms, so x squared minus 8x plus 10. Holy bananas. X to the fifth, negative 8x to the fourth, 10x to the third, plus 4x cubed, minus 32x squared, plus 40x, minus 2x to the fourth, plus 16x to the third, minus 20x, minus 8. Oh man, look at all the room that this is taking up. This is a big one. Minus 8x squared, plus 64x, minus 80. All right, like terms. There are no other to the fifth, so x to the fifth, you're out. Okay, so that's an x to the fourth, that's a third, that's a third, that's a squared, that's a 1, that's a fourth. Let's see, we can say IV, right, for 4 in Roman numerals. Third, first, second, first, nobody. All right, so things with IV, negative 8, negative 2 make negative 10, x to the fourth, got rid of you. To the third, 10 plus 4. 10 plus 4 is 14, plus 16 is 30. X squareds, we got 30, negative 32x squareds, and negative 8x squareds is negative 40x squareds. 40x minus 20x is 20x, and 64x is 84x. And minus 80. It's a beast, but it's good. All right. Last couple of little pieces here. Descartes' rule of signs. What we're doing with Descartes' rule of signs, we're figuring out how many of what kinds of answers, zeros, solutions, solves, x's, intercepts, all that other stuff that it's called, how many of each kind there could be. I mean, we could graph it, we could see which ones they actually are, but we can tell how many there could be based on the rule of signs. The number of positive real zeros is how many changes in the sign of the original function. The number, and less by even numbers. So less by 2, less by 4, less by 6, because that could be, because if you have any imaginaries, they come in pairs, plus or minus. The number of negative real zeros, the non-imaginary ones, is if you change all the signs in the problem first, and then you count all the sign changes, like we did in the last. Or less by an even number, because the imaginaries come off in twos and pairs. So let's see what this means. Okay. Determine the possible number of real positive zeros, real negative zeros, and imaginary zeros. So the way this works, this has a positive sign. So from here to here, that's a change. From here to here, that's a change. From here to here, that's a change. And then it doesn't change after that. So there are 3 changes. So for positive, there could be 3 or there could be 1. Now negative, we have to change the signs first. So this would be a negative, that would be a positive, this would be a negative, that would be a positive, that would be a positive, that would be a positive, that would be a positive. So now let's count sign changes. From here to here, there's a change. From here to here, there's a change. From here to here, there's a change. And then not, and then not, and then not. So for negative, we could have 3 or we could have 1. We're supposed to have a total of 6. So here's how this gets interesting. If I had 3 positive, I could end up having 1 negative. If I had 1 positive, I could have 3 negative. But I have to have those combinations of things. And this is my imaginary piece. If I had 3 and 3, I wouldn't have any. If I had 1 and 1, I would have to have 4. If I had 3 and 1, that makes 4, I'd have to have 2. If I had 3 and 1, that makes 4, I'd have to have 2. Those are all the possible choices that I could have. If I had 3 and 3, I'd have none. If I had 1 and 1, I'd have 4. If I had 3 and 1, I'd have 2. If I had 1 and 3, I'd have 2. And then I could check and graph it and see what I actually get. That's how that works. Lastly, the word problem. They give you a thing and they say, here's what it equals. Find the place where it equals that. So the easy way to do that is to graph it. You just have to know what to put where, okay? So the speed x of the engine shaft, and then speed s in miles per hour of the boat, 15 miles per hour. See how I did it in blue? That's speed s. S is on this side. X is on that side. So 15 equals all of this stuff. Now, what you could do is move the 15 over, set it equal to 0, find out where it touches the x-axis. The other thing you can do is make one side y equals and make the other side y equals, which is what we're going to do. We're going to say y equals 15. And then we're going to say y equals 0.00547 x to the third minus, move that over, 0.225 minus 0.225 x squared plus 3.62x minus 11. And what we have to do is look for where they touch. Dunk. So x is approximately 19.863 RPMs in the 100. Okay, or 1900, we could probably move that over, 1986.3 RPMs. Okay, but that's all you have to do on those is put one equation one way, one equation another way, solve. You can try some of these for practice. Try the ones in your book. I'm not going to go through the answers on these, but that's how they work.